Hello and welcome. Today we are going to see a Leetcode problem, diagonal traversal 2. The question is pretty straightforward. We are given a 2D integer array nums and we have to return all the elements of num in diagonal order as shown in the figure below, right? So we are given this 2D array and we have to return the elements diagonally. So 1, 2, 3, 4, 5, 6, 7, 8, 9 are given and we have to return 1, 4, 2, 7, like the diagonal elements basically. So the example number 2, when you see, it's kind of a little bit tricky. So here we are given with 1, 2, 3, 4, like the basically the 2D two-dimensional array of different length, right? And we have to return the diagonal elements as you can see in the figure. It is clearly straightforward. So let's see how we can do this thing. So we are given with an matrix something like this: 3, 4, 5, and then 6, 7, and then 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is our matrix. So now what we can understand from over here from this is, like, since we have to return elements something like in this order, right? So this is our order in which we have to return the elements. So if you see, we need an array to store these elements of size basically n plus m. So what I'm saying n plus m minus 1 is like the length of this row, the number of rows. So 1, 2, 3, 4, 5. We have 5 rows, right? And the maximum length of the column, which is 1, 2, 3, 4, 5. This is the maximum length of the column. So 5 plus 5, 10, minus 1, 9. So we need such 9 elements over here. So what we are going to do is, like, we have to create a, sorry, we will create a vector of size n plus m minus 1. So this vector will basically contain these elements diagonally. So what will store is like, so for the position I plus j, so suppose we'll run a loop from two loops, like for I equals to 0 to the row size, which is our, let's say, n as of now, and I plus plus, and then for j equals to 0 and j is less than the like nums I dot size. So basically the size of the ith column, the size of the ith column every time. So every time, and we'll create a vector something like this. So this will be our temporary vector, wherein its size will be its entire size will be I n plus m minus 1. So we'll add, like, we'll insert all the elements of this given array into our vector position wise. So for the element at I plus jth position will be inserted in this array. So for example, this one is at 0 comma 0, the sum is 0. So at 0th position we'll insert this one. Again we'll see for this 2. So this 2 is at position 0 plus 1, right? 0th row, first column, so 1. So we'll insert 2 over here. Similarly we'll insert 3, like we'll insert 3, 4, 5, right? Now let's look at this 6. This 6 is at position, it is at 0 comma 1, right? Sorry, 1 comma 0. So this is at position 1 comma 0. So it's again sums to 1. So we'll just push this thing to this sorry, not this position, the 1th position here. 7 will come to this position. 8 will come to, 8 is at position 1, sorry, 2 comma 0, right? So its sum will be 2. So the 8 will come here. 9 is at 3 comma 0, sum will be 3, so it will come here. 10 is at 3 comma 1, which will be 4, so 10. And then 11 is at 3 comma 2, right? So 3 to 5, so we'll put 11 over here. Similarly 12 is at 4 comma 0, so we'll put it at 4, 12, and then 13. We'll similarly put everything 14, 15, 16. Yeah. So at all this position, we'll put all the elements given in the array. And now if you see this thing, and also we have inserted this thing in a stack. So we have used stack data structure to insert these elements. So we'll just push these elements in our stack. I hope you are understanding. Now what we'll do is like we'll create our answer array, and in our answer array we'll pop the elements from the stack. So from the first stack we'll pop 1, from the second stack we'll pop 6 and we'll pop 2, right? From the third stack we'll pop 8, 7, 2, fourth stack 12, 9, 4, fifth stack 13, 10, 5, and similarly 14 and 11, right? And then 15 and then 16, and I hope this is our answer which we are going to return. So this is how we can return our answer. So if you look, if you see our output, it's similar like 162,873 and whatever we have seen in our uh, this answer, right? So now let's see how to code this up. So here is the easiest code for your explanation. So what we'll do is, so we'll basically n is the size of the array, the length of the array, the row size of the given array, two-dimensional array, and as of now we have initialized m with 0. Now we need to know the maximum column size. So given a row we need the maximum column size. So what we'll do is, for every row we'll check the size of the column, and give size of the column is given by the row size, right? So every row, the longest row size will take m and the row size, and whichever is the maximum will update m with that. So now using this loop we have our column size which is the maximum. Now we have both n comma m. Now what we can do is like we'll create a vector of stacks. So we have seen that in over here that we have this this is our temp vector, and this vector consists of stacks, multiple stacks, right? So all these are stacks wherein we'll be pushing our elements. So in this vector we'll initialize our stack, and after that what we are going to do is like for each row and for each element of that row we'll be traversing till the size of that row, we'll push that element in our stack. So which stack? Temp I plus jth stack. So whichever stack correspond to that position, we'll be pushing that element in that stack. So for example, suppose we have taken our elements which is something like let's say this 10th element, right? So where are we gonna push this element? So 10th is at position 3 comma 1, right? 3 comma 1 in the array. So 3 plus 1 corresponds to 4. So we'll be pushing this 10 in fourth stack. So see, if you can see 10th it pushed over here, right? So we'll be pushing all the elements similarly, and then we'll initialize a vector answer which will consist of our answer. It is basically a data structure to hold our answer. Now we will be traversing through this entire array of stacks. So the vector of stack which we have created, or let's say array of the stack, it's basically vector of stacks. So we'll be traversing through each vector of stacks, and we'll be looking at that stack, and while that stack is not empty, we'll be pushing the element of that stack into our answer vector, and we'll be popping that stack. And since our stack is empty, since our stack is empty, we'll move to the next stack, and similarly we'll store all our answers in the answer vector, and we'll return our answer. The time complexity of this entire program is so over here if you see, it will take OF n, like n basically n is the size of the entire entire vector, not vector, entire 2D array which is given to us, and we will be creating stack. Yeah, again pushing it in stack, pushing in stack takes OF1 every push operation. So again this will be of OF n 1 into n size. So again this will be O of n, and popping from stack and keeping in our answer arrays again of size n. So we are using OFN time complexity, and for our space complexity, since we are creating multiple, we are creating multiple stacks. So each size corresponds to, like, the sum of the stack size again corresponds to O of n, and our answer vector is again of O of n size. So hence we are using O of n size of stack and O of n, so our time complexity is also big O of n and our space complexity also big O of n. I hope you have understood this problem. Thank you very much.